Hello, this is video 4 in the series What if they had 3D? And we're working on a bicycle, an old-fashioned bicycle called the penny farthing bicycle, and that is the bicycle with a very big front wheel and a very small rear wheel. And we just made the hub for the rear wheel, and we are now at least one part of the hub. It's actually an assembly, so we're going to continue with actually the shaft and some nuts and bolts to make it work, you know. So let's start. I'm going to start again with the standard template. I'm going to name this thing, Control Save. I call it shaft 2 penny, because 2 is the penny and 1 is the farthing. Okay, so and let's also take into account this hub. So we are going to use dimensions from this hub and use them in the shaft. So we're going to connect this one with this one. Alright, let's start. So we're going to start with a new sketch again. I'm going to make some rough sketch just to have the sizes, and I think it's about right. What is the length? So I typed the M for measure. It's just 23 millimeters. Yeah, it's about, I'll make it a little bit longer, because what was the length here? Measure M 75, right? So okay, let's take this down. Measure 44, let's make it 100, so that's about twice the length. Okay. And I say shaft length 0.1. So now, actually I should, if I do it correctly, I should make it shaft 0.2. Let's do that. 0.2. The word penny is not necessary because it's already distinguished with shaft 1, but we don't make yet, but we will make it in the future. So let's say, I don't know, 120 millimeter, and the diameter, say shaft 0.2, dia 0.1, let's say 20, and basically this shaft is just a shaft with screw thread on it, so but it will be fine thread, and we will take care of it later. I'm not sure I'm going to do it different, because I'm going to make this dependable on the hub, and I call this extension. I'm going to add a extension. So shaft, I'll tell you, you'll see what happens. Shaft 0.2, 0.2, extension. So 0.1. Okay. And we're going to add this link So we're going to add this one, right? So what do we need? We need this length, right? So check it out, and here you see it's added to the connections. So we want to make this about 120, so I say I copy this with Ctrl C and I say is hub length plus times 2. Now when it is red it's not completed yet, so now it's complete. So I've now, actually it's not, obviously not, it's not 1 millimeter, so we make this like, what will it be, how much will stick it out on both sides? Let's say, I don't know, 35 millimeter. Let's make it 30 first, okay, and then we'll see what happens. So now we make this thing symmetrical. I'm going to add the x-axis and the y-axis, so I now can make this thing symmetrical. And this one too. Oops, that's wrong. So again, this one, and the middle line. Okay, now it's symmetrical. Actually, I should do this half, so I'm going to remove this one and I'm going to make this trim. And we're going to make this a thick center line, and now we're going to add this length. And we say shaft to length. There you are. And now we're going to say the diameter. There you are. And now we're going to finish the sketch and we make it, I'm not sure if I need to add this line or not, but I'm going to revolve it. What if I make a section, what happens? Is it then hollow or not? That's the question. No, it's not hollow, so this is good. We're going to add a material, let's say steel mount. Assign to selection, okay. We have some chamfers, not a lot. Shaft 02, chamfer 01. It will be 1 millimeter, yeah, 1.5, okay. And that will be later, because you're going to make a thread also. So what's the diameter again? Measure 20 millimeter. It's kind of big, but maybe let's see. So let's first make the assembly. So now we're going to make, because I want to see how it will fit in. So new. Now we make this assembly of the hub. So hub to penny, but it's not, it's the assembly. Okay, so we just, you can do this whatever you want. I just have the same name, but I use the AIM extension, which is an assembly. So there you are. Save it, put it in a vault, and take it. Check in. It's in a vault now, although it's still empty. And check out. Right. And now we're gonna put this shaft in. Just copy There are other ways of doing it, I just like to copy it. Because this is the core thing, so I'm going to ground and root this thing. Alright. Not like this, not grounded like this, but grounded with flushes, because that's more controllable. Okay. So now we're going to add this shaft, the hub. Ctrl C, Ctrl V, and we're going to do the same thing. So now we have a problem. We see that it is like a little bit too big, so we need to adjust on both, you know. So let's make a section and see what happens. Okay, well, there are several ways to approach this. Both are in the middle, they're all symmetrical now, so that's okay. But we see that the shaft is way too thick or the hub is way too thin. So we need to deal with both. Well, and there also will be a bearing, you know. I don't know exactly, I'm just gonna guess everything because that's basically the best way at the moment. So I'm gonna add some bearings, and it will be a roller bearing. I'm not sure if they had it back then, but just let's assume that they had it. So I'm gonna make a roller bearing, and it will probably be the same for both. So I'm gonna say standard. So ball bearing. It's actually a ball bearing, I'm sorry. Save. Oh, that's not the save button. Save. Ball bearing 01. And I don't know how that will be like. What will it be? 3mm, I guess. It's just new sketch, and then I'll just make a circle, and I'm gonna make diameter ball bearing dia 01. Let's see, let's say it's 3mm, and then I make a dimension. Alright, zoom in a little bit. I zoom in with my mouse. There is the scroll wheel, and I use that one. I have it on steps, but you can do it without steps, but it's whatever you want again. So, but I think we need to cut this in half, otherwise we cannot make the revolve. So I'm going to cut it in half. I'm going to add an x-axis and an y-axis, y-axis. And then cut it in half, trim. So, and then end the sketch, revolve. See, and now I forgot the center line. I can still choose it, but I like to just pre-define it because it's actually, I think it's more accurate. Maybe I'm too much of a purist, but steel, well, it will not be steel mild, but for the sake now, I don't know, let's make it nice and polished. Okay. Right. And these ball bearing will be in an array, or in a circular pattern. We will take care of that later. But the important thing is the diameter is 3, so I'm going to use that one too, by the way. So I'm going to use the diameter of the roller bearing because we need that one too. There is a round edge, so we're gonna use this hub, and that's the beauty. If you use an Excel, you can do it all in one. I'm not going to do it now, but let's say this is the hub. This is the hub. I'm going to close this one. Yes. I'm not going to check it in. No, because I let it open, as it were. The shaft I'm also going to check in. And check out again. I think it's wise to do this. I'm going to use the hub. I'm going to open it again. And I'm going to put the roller bearing, the ball bearing diameter in here. So, what was the name? Yeah. I'm just going to name it bearing dia 01. Yes, check out 3, and now I'm going to make the ball bearing dependent on the hub, because then it's all connected. So link, bearing diameter, yes, export the thing, and then we say okay, list parameters, bearing diameter, there you are. Because if we change it here, it will change here. If it changes in the hub, it will change in the ball itself too. Because you need it in the hub, I'll show you why. Because we're gonna make, we're gonna change the sketch a little bit. Edit sketch, and we need to have space for the. So I'm gonna change this. I'm gonna throw this away. Let me not. Thickness 02. This, I'm going to change this thing. So hub thickness 02 we're not going to use. We're going to rename it hub dia 02. Oh, it's already used. Edit. Dia 03. Yes, and this will be, let me say, 22 millimeter. Let's just say something. So up the 03. Now, and this makes more sense. I think it's still too big actually, but I'm going to make the shaft diameter here also, because the hub will determine everything. Hub shaft dia 01, 01, 1, and then let's say the shaft is 16 in diameter. And now we're going to take the shaft and we're going to use right, and here we have the shaft diameter. I already made a copy, so it will be 16. This makes more sense. Update. And now when we look at so that's another thing that I want to say. I use these tabs in a certain order, and the reason why I do it, because if you go to the far left, you have the whole assembly, and then you go to a sub-assembly or to the part that determines everything, which is in this case the hub. sorry about it, I need to put it here. So, and then we have this, the shaft, which is being determined by the hub, and then we have the assembly, and yeah, you can debate about it. I think that the assembly would be better if I put it here. So here we have the whole assembly, here we have the, the hub, and let's finish it. So, and then we have the two. So the more you go to the right, the more dependent they are on other things. That's basically the idea. So that helps you navigate through your process much easier, so that you don't need to look up all the things all the time, you know. So now we have this shaft diameter, and we have the hub diameter, yes. And so there is, how do I explain this? We need to find a place for the roller bearing. There will be here one and here one. So how do we do this? It will be some kind of a cylinder here, and then it will be thinner here, you know. So let's do this. We draw this line, and then we will later adjust everything, of course. Enter, and then I have the line command again. So and I'm going to make another parameter, hub shaft space 01. I'll show you what I mean. I needed 1 millimeter, so I have this diameter, and it will be the shaft diameter, shaft diameter plus the space that I just made, which makes it 17, right? So, and then we have another length. I'm now sorted on this order. Now it is. Now we can see the copy length 3. Let's say that is, I don't know, 60, and I'm going to make this symmetric. And we're going to give this a length. It will be length 3. It's about 60 already. And I think this one should be a little bit bigger, or the other one should be a little bit smaller. But let's just pretend that it's not the case yet. So we're going to make this ball bearing. We're going to put the ball bearing in this area, but just the form only. So let's see. So, and we make this construction line, so it doesn't influence the rest. So we're going to make this tangent constraint on here to here, and then this one from here to here. Now, and then we're going to give this the ball bearing diameter, right? So what was it again? Bearing diameter, yes, there you are. And I'm going to mirror this thing. Let's wait for mirroring. How does this look like? There's an error, I already know, because edit sketch, this line should be gone, this middle line. And what happened? This dimension is disappearing. Hub diameter 3, I mean, I copy it. Now I trim, trim, and I put the dimension here again, Ctrl V, and they are both black, so they are dependent on each other. And now I'm going to finish it, and I'm going to make this section thing because it gives me a better view of what actually I can better look here. See, this is, I can update it. Now we have this section, and we are almost there. Let's make the, here is a nut coming with, which actually closes in the balls of the ball bearing. So I'm gonna make this nut now, and I'm gonna also make that dependent on the rest. So I'm gonna put here the nut diameter, because also the nut diameter is dependent on what else is going on here. So hub nut dia 01. That's the outside diameter, of course. So let's say it will be where's the shaft diameter? It is this one plus, I don't know, what shall we say, plus 4. I will make it 6. So now so now I'm going to change this. I'm going to make this nut, the nut, I'm going to save it. One thing I always do, or when I think about it, I recommend saving the moment you start with a new document, if it is Excel, Word, whatever you make, because many of these software, they have an automatic saving program in it, and so, but if you don't give it a name, it gives it its own, it makes up a name, and they put it in the user, and it becomes some secret place. It's very hard to find it back, so just give it a name on the right directory, in the right path, in the right folder, so that you can always find it back once your computer crashes or you lost it for whatever reason. Okay, so nut .202 penny. I just call it nut 01. I'm not sure if I have more. You can always change it. Save. So save, and now I'm gonna make this nut. Let's start with the XY plane again, new sketch, and we're just gonna make like this. And then project geometry Y, X, and then I'm gonna link again with the hub and shaft dia, and whatever you had also had the nut dia. Right, so nut dia 01, and I just And you can also go directly, you know, you can use these things directly. I just don't like it because I want to have control in my own model, you know. So, but it's not a law, not length 0 1, not fillet 0 1. Let me see something. And then we have the nut across flats, nut, because we need a range 0 1 to mount it. Let's say that is, I don't know, 24, and this will be, the fillet will be the ball bearing diameter divided by 2. So link, where is the, right, there you are. So divided by 2, not length, I don't know, 40 millimeters probably. Okay, so now we have the nut length. Maybe it's too big, we'll see. Nut length. And then we have, let's make this center line again. The diameter. That's not right, but I'll check it later. No, I cannot do that. I'm gonna connect this line with this side. So now it's all, and now we need to find the inner diameter, and I thought I had it, but not dia 02, and that is the hub shaft diameter. And that is this one, copy. Right, and now you're gonna finish this thing, F6, and then revolve it. There you are, metal, steel, just switch from mild, and then we will find steel mild. Side to selection. Now we're gonna make the and then I'm gonna add this across flats. It's rectangle, but when you click the little arrow here, you can have a polygon. And we're going to make this horizontal. So now, and now this is the across flat for the branch. Let's see, is that, there you are. And I just call it length 2. because you have this where you have the wrench, so that is like, what is it, 10 millimeter I guess, something like that. So extrude, let me edit the sketch a little bit, and then we're going to project this geometry, so now we have a perfect, you're going to extrude this part, the other side of course, and then we say, I just made it up, length 02 I believe, yeah. So now we have this nut partly, and we need to make a rounding here for the ball bearing, right, for the ball, yeah, and so we have that. So I'm gonna edit this sketch, and we're gonna, as it were, I need to make a PCD for the ball bearing basically, so let me do that here. Pitch circle diameter, let me put it here, let me go here, no, edit sketch. So the ball bearing, the middle point of the ball bearing is going in the system, right? So we need to place this ball bearing in the right position so that it will fit both sides. So that's why I make a pitch circle diameter, which basically puts the middle point, the center point of the ball bearing in the right circular system. So ball bearing pitch circle diameter 0.1. What shall we say? I don't know yet, because I need to measure it actually. So how will this be? It will be 19, right? So let's say and now you see that this one is actually, so if I add this dimension, it says add this dimension will over constrain the sketch. Why is that? Because we actually have these two constraints. You see these two with this one and this one are connected with this line, and this one is connected with this line. You see, so both are green, that means they are connected, and this is green, this one is green too. So we better, since we make the pitch circle diameter the determining factor, we're going to make this line, this dimension I mean, driven. That means it's passive. So now it's just a value that it determines, and now I'm going to put this pitch circle diameter here, and I call this bearing pitch circle diameter. There you are. So now that determines where the ball bearing is. So I'm going to save this thing and save, and then here I have again not bearing PCD 01. I'm going to derive this from the hub, right? So it's not here, so I'm gonna do this again. There you are. Export it. I'm not sure if I can. Oh, that doesn't work. Bearing PCD, there you are. So now I'm going to have this bearing again somewhere, and So I'm also going to make here, I'm going to open the sketch again. So this length is also determined by the bearing length, right? But I can use the hub length. Okay, let's just rename it to bearing distance. So it was hub length 3, hub bearing distance 0,1, and let's make it 64, something like that, or 65, whatever. Let's just try something, and then we're going to make this. We're going to change this. We're going to move this dimension to the other, to this one, right? So we're going to draw this. We're going to mirror this one. Mirror this. Apply, done. And then we're going to remove this dimension, and we're going to say here and here, and now I put the dimension again. Let's see, is this, I'm not sure if this is connected. Let's see. Oh, it is connected a different way. It's all black, so it will be good, you know. I'm going to move this dimension here, so when I zoom out I can still see what it is. The names of this dimension you can change, by the way. So here, when you click this little button here, you can, the dimensions don't change, but you can see, okay, let's see, let's click here, just value, displays the, what does it say? Display as a calculated value, okay. And the fx means it's determined by, it's actually a name. Now you can see the names, D38, that's the internal name. And then here you see the expression. Here is the names that we give in the parameters format. And then here is the tolerance, which we don't use. And I just prefer this one. This is most, it's not too big also. The text is not too big. So, excuse me, I'm using this one. So here you can see the values. You can see fx, it is named, and you still see the value of it, right? So, okay. And then what we are going to do, we're going to make this now not a construction line anymore. Needed this one, not a construction line anymore. And we're going to just trim. Let's see if it works, because it might not work the way I like. Maybe I just leave it. It's probably easier. And then I'll fill it later. And now, when we look at the, we're not there yet, but we are coming there. So this shaft we're going to edit, and we're going to add this ball bearing somewhere. Sorry, I'm wrong. I'm sorry. We're going to use the nut. Sorry about it. So let's finish it now. Yeah, here we are. So I'm going to edit this sketch. And is this still correct? Yes. And we are going to do the following. Not the, I'm going to change that. I'm going to remove it actually. I'm going to make it dependent on the ball bearing. So I'm going to remove this one to here, and you is the ball bearing diameter. There you are. We probably need to change this PCD, so let's do that. Let's do that. Where's the PCD? Make it 20, because we are getting in trouble. Back to the nut. Update. Sketch. You see it's now 20, so this is better. And then I'm going to trim this line. Trim this line and trim this one, and this is not what I want. I'm gonna move this thing. Let's see if I can move this thing. I see what I need to do. This one I need to remove. I click this little red button. And now I can move this thing here. And now I put this little dot, which is the center point of the ball bearing, here. And now I'm gonna trim this and this. And this thing is still connected to this line, by the way. So let's for now just give this a thickness just to finish it. So it's kind of thin. Let's do 2, something like this. Right. And now we have something that we can work with. Let's see how this works. Add this in a assembly. Where are you, assembly? Here are you. The nut is gone. I don't know where it left. F6. Where is it? Oh, here. Ah. And it is there, but it is behind this the section, you know. So that's why we couldn't find it. So we're gonna ground it partly. I just first ground it, and then I'm gonna remove this connection, delete, and now I can pull it out. Come on, baby. Okay. Wait a minute. I do not know why this is happening. So I say free move, I click this thing, and then I can pull it. And now it goes back. Okay, I'll just remove it. I do it by hand. I don't know why it's not. Why it's not working. For some reason it's stuck. I just delete it. I'm gonna do it again. Place. Nut. You can do the axis. You can constrain it on the axis. I don't do it because I don't want it to turn all the time. So I just do this plane and then this plane, constraint, And constraint is like two planes on each other. So okay, let's see if this now works. Yeah, and then this one and this one. I think it's the right one. And now it should be able to pull it. Yes. Right. So here we have, this is 16 millimeter, and the shaft is also, I mean, the shaft diameter is also 16 millimeters. So now we can make threads on it. Okay. I think this is too long, but we'll see. So now I'm gonna make an assembly with the ball bearings. You can put them all in loose, but it's kind of not working. So I'll make an assembly. And I save it as ball bearing. I just remove the extension, and now it's like IM assembly. So I put it in the vault, and I take it, check it out again. Now I can work with it. Check out. So now I'm gonna take again. I go to the hub, and I'm gonna find the bearing pitch circle diameter, which we need, and I'm gonna take bearing PCD derived, because we cannot use the same name. 01. That's 20 millimeter. I think that's wrong, but we'll see. Place, and then we're gonna get the bearing. So, okay, I'm gonna use one of the planes. F6. So this plane is going to this plane, and we're gonna merge them or connect them together. Apply. So, and then we're gonna make a distance. So this plane this plane and this plane we're going to merge, we're going to connect also, and then we're going to make a distance. Let's just let me just change auto size, and then I'll make the planes visually and also the x-axis, and you see what's happening. Visibility. So here I'm using this as the axis for the pattern. So I'm going to pattern these things. Pattern this one. It's a little bit different interface, but it is about the same thing as the circular pattern in the part. So here the company where I've chosen, it's red, so it's selected, and you're going to use this x-axis too, and then I forgot to add a number, so how many balls are we going to do? I don't know yet. Now we have 4, we probably need to change it. So now you see, let's put in here the number of balls. So because I want to have the hub determine everything. Hub bearing ball bearing number, right? So number 01. You make it a unitless. Enter, and then, now let's say, I don't know, 16. We'll see what happens. So we're going to derive that number again. Link, hub, ball bearing number. I didn't take it, wait a minute. Hub, click, yes, okay, and then bearing number derive 01. That's also, and it looks a little bit extra. Why you do all this extra? The thing is, when you change it, then you are really saving a lot of work, and we need to probably need to change it a lot. So that's why it's seemingly extra work, but it's really not. That's the same one. So this one. Now, and now we're going to use edit this component pattern, edit, and we're going to use here why is it not working? Edit, yeah, so it's 360. Oh, it is, yeah, that's a little bit weird. So it is 360 divided by, there you are. Okay, 16 is clearly too much. So we're going to make it half for now. 8. Save and then update. That looks a little bit better. I'm going to remove this. Visibilities. I leave this for now. But save it, and now we're going to add this bearing in this assembly. Copy. Let me just check it in first. So we see that there is something wrong, so that the pitch circle diameter is clearly wrong. I don't know why that is, but just let's put it. Again, I'm going to use the planes because that is most clear. Apply. Where are they? They're gone. Okay. But we can find it in the browser, and we can just do the free move button, and here it brings it out. Okay, so now we are back. By the way, I have a mouse and a mouse button, and I have programmed one mouse button with the command escape, and that is because, and I recommend that because you use the escape button a lot, but when you need to move your hand to the keyboard for the escape, it's just, you know, so your thumb is just faster. Okay, let's move this thing. Constrain with this one, and then it's hidden again because it puts it in a certain place. Free move. Okay, free move, there you are. So, okay, clearly there is something really very wrong here, and I don't know why that is. Oh, it's not wrong at all, okay. But we can clearly see that the pitch circle diameter is not working, right? So let's see what happened. I'm going into the sketch. Yes, I want to check it out. Bearing pictogram is 20, okay. And here, what is it here? It's also 20. So what's going on? So here, I mean here, let me see if I make a section. So we make a section. I'm gonna click this thing. So what is wrong here? So I just measure the distance from this one to this one. That's 10. See? That's not 20 at all. So what happened? I know what happened. We just didn't. See, it's still loose. So we need to make another constraint. So where are we? This one. Constraint towards this one. And we need to add pitch of a diameter divided by 2. It's a half circle, right? So it's that. Edit. And there is something wrong here, but it has to do with accept. Probably you need to have them reversed. And now it's gone. And now we can use 16, right? So that's going on. Let's see how it works out in the, there we are. So let's make a double section. So yes, so then we do, wait a minute, so quarter section. Right. So we're going to use this plane and then here somewhere. Now we can see what happens. So, well, we can go back to 16, I think. Finish. Let's make them 16 again. So 16 bearings. Save. And then it magically, there are 16. I believe this is realistic. You see? And now we're gonna go back to the normal. Click no to delete. This one. Alright. We can also have another view and we can make this thing transparent. So we're gonna go here, right click, transparent. Isn't it nice? So now you see how the things fit together. And you can also arrange these things better, you know. So this thing is obviously too long, so let's go to it and just open it and just change it a little bit. So the length, let's make it 20 and then we update it. This looks more real. And we're going to add thread to it also. So let's add a little bit thread. So that's also the nice thing with this program, at least, and others too. So we have thread and it's probably not the right thread at the moment, but it doesn't really matter. So I'm going to click this and it's actually fine thread. Let's see if we can get it here. So ISO, they didn't have ISO of course back then, but it doesn't matter for now. M16 times 1, this looks pretty fine. Okay, this looks realistic to me. Use this one and then enter, and then we're going to use the shaft, also has thread, but it's only partially. So I'm going to add a value thread length. We don't need to put it in the other one. Shaft thread length 0.1. What shall we say? 20 millimeter. Just thread. Select the surface, and you can say here, I believe, depth. Yeah. List parameters, shaft thread length, and we did M16 times 1, right? So this looks pretty decent, and we're gonna mirror it because I don't wanna, and that's why I always, or in most cases, I make things symmetric, so the middle plane is here. Many people start and they make, and then the middle, this plane would be here. But then you cannot mirror it, and you need to make an extra plane to create a middle plane. That's why if you start symmetrically, you will always, well, in most cases you will be, it will be much more easier and quicker to work with. So I'm going to mirror this thing. Where are you, mirror? Oh, here, mirror. Oh, it cannot be mirrored. Okay, too bad. Then we just do another thread. And times 1. It already has the right thread in here. And now I put this chamfer on it, which I tried before. I thought about before, but chamfer. Yeah. This one actually should be 1 because the thread thickness is 1, but the thread, the depth. Where are we? 1. Update. Save. Let's see how it works out. Yeah, we need some more, I think. Let's still make a section. You see that that's not enough. So let's make the thread length 40. And if I make, you can, that's the, look, this is again, here you can really see it live happening. You make it 40, and you say done, and you say update, and it's, see, it just has both changes. It's so much easier when you work with these parameters. It's just wonderful. I do by hand now because it's at the moment easier, but we actually should. Well, what we can do is, since this face is equal to this middle plane of the bearing, so let's just, that's better even. So I'm going to just constrain this face. So I use this face, and because I have a section I can easily reach it, you know, and this is the plane. I don't know if I need to do this one. Edit, I need to do this one. Yeah, you never know. And now we can mirror them. now we are getting somewhere, you see. So pattern, I made this symmetric again. You can mirror it. I don't really like to mirror parts because I'll show you what happens. And this one, and it creates, let's see, and it creates a whole new system, and yeah, because here you are, it creates other new components, which is completely unnecessary. So let's forget about all this, and what I do is this. I make a pattern, but it's mirror, right? So how do you do that? Well, you can also use the rotation, the circular pattern. So I use this shaft, axis, the Z, and I just say 2, and it's 180 degrees. I don't know why you need to do this twice, because actually it's double work, but that's how it is. I don't know what it is. And now we can just say okay, and now we have a component pattern. That's actually what we want, right? So now we have the hub, and we have the shaft and the bearing and the nut. So we are a lot further. Let's make this normal again. So here we are. Now we have the whole thing almost complete. There's more to do, of course, because we also need to have the fork of the bicycle needs to be connected. I do not know, I have not taken care of that yet, so I'm just gonna make the wheel now, just to have at least something that we can look at. So I'm gonna make another assembly, and the beauty with many of these type of software is that you can put assembly in assembly in assembly, you know, so that is really very helpful. And we're gonna add, I'm gonna name it the wheel 02 penny. So that's, and I'm gonna add place just click, and now I'm gonna ground and root without origin. You can ground with origin, many people do that too. Let me just show you what happens. So I'm gonna undo. So this thing is now free to move, right? And what many people do, they do this. They just right click it and ground it. What happens is it can appear everywhere. So let's just show these 3 planes, and now let's show these planes. You see, they're completely asymmetrical, they are just random. So I will always use the planes, and that's actually a possibility in Inventor. So when you just, let me right click and I do unground it, and now the thing is everywhere. But then I use this ground and root, and then you look carefully. Grounded origin, I don't do that because that is just, then it appears where you just dropped it. I say create origin flushes, constraints, and reposition at the top of the browser. The top of the browser means this, that's really not that important, you can always change it, but this one is really crucial. Create origin flush constraints. So that's what I'm doing. I selected object, I click OK, and now see, all the planes are connected to each other. That's what, and here you see a plus, that means the planes are all flush with each other, it means connected. So this is, and I click now F6, it means zoom all, and now the whole thing is in place. And now I'm gonna place the wheel also. Where is you? Wheel, where are you? Wheel oh, I call it rim to penny. So again, ground represents the top of the digit. I'm not needed now. So now the whole thing is. Now we have a almost a wheel. You see, with places for the spikes and everything. So the spikes is a story on its own. I'm not going to do that right now. But I just wanted to show you this thing, and we'll see how you like it. So here we have made the hub with the hub itself, the shaft, the ball bearing, actually the ball of the ball bearing, the nut, the ball bearing as an assembly, and the whole wheel. Well, thank you for watching. Thank you for watching, and we'll see you next time. Thank you very much.